Okay, our objective for today, I can solve and graph quadratic equations by completing the square. Let's read together. 1, 2, 3. That is correct. So we're still on quadratic equations, so you don't need a Fourier model. Okay? And today's method is completing the square, so we don't need a Fourier model for today. So pens down, eyes up here really quick. Let me do a quick intro to completing the square. The term itself, completing the square, it's fairly obvious. But to see it, you need to see it first. I'm going to show you once again. I try to introduce quadratics with algebra tiles. You guys remember when we did algebra tiles for factoring? Same thing could be used for completing the square, but today I'm not going to give you the tiles, but I'm going to show you with tiles. Look up to the screen. Let's say I start off with these four and this. Pay attention, please, or you're going to miss it. Therefore, tell your neighbor what is the polynomial so far. Okay, so our polynomial is x squared plus 4x. So if I was to ask you for the next step when we did factoring, remember I said make a rectangle, right? But instead of rectangle, what are we focusing on today? Square. So I'm going to make a square out of this, which means I need to evenly split these up, right? Which means it's going to be 2 and 2. So watch. 2 here, and there's my square. So now check this out. I don't know if you guys notice, but here there's a big gap in order for me to be a perfect square. Does everybody see that? So to fill that gap, what do we need? So therefore this trinomial, or this quadratic trinomial, to complete the square, we need to add 4. Everybody understand that? That's what we call completing the square. Yeah, and rectangles are squares, yes. Yes. So, look up, yes. You'll see right now, yes. No, this is just a process so you understand what completing the square is. I'm going to give you an equation, a trinomial, but we're going to use this process. So look up, please. I'm going to do a couple more. So I'm going to go now, and I'm going to do x squared plus 2x. Let me get my tiles. Can you get the left light, please? Here's x squared and 2x. They're right there. Are we there so far? And I need to make it a square. All right, so then I move this. Is that pretty close? Yeah, so if I was to complete the square, so I started off with x squared plus 2x, and to complete that square, I needed to add 1. Is everybody following so far? Okay? All right. Let me use another one. One more. How about, let's see. Look at this one. Okay. Yeah, tell your neighbor how would you split that up to make it a certain. Okay, so I heard 4 and 4, so let's see. Therefore, so there it is. So we started off with x squared plus 8x, and to complete this square, let's see, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We add 16. Yes. We'll get there. Okay. Are we there so far? Okay, hold on. So let's see. We got this one to get this one to get this, and this one to get this. There's a pattern, guys. I'm going to show you this next one and see if you see the pattern. But instead of just using tiles, I'm just going to use algebra. Here we go. Pay attention. X squared plus 10x. All right, to complete the square, check this out. Don't say it out loud, please. I'll show you another one. X squared plus 16x. Let me complete the square. And one last one. X squared plus 20x. Let me complete the square. Okay. I know some of you already got it. Hold on. However, this is what I want you to do. Look up, please. Don't say it out loud yet. Now, check this out. In terms of this, let's say I gave you okay. This is a standard form equation, yes? So, in terms of this, think about this before you start talking to your neighbor. How can I explain the pattern of completing the square using some terms from here? So think about it. Knowing this, how can I complete the square for any trinomial using this terminology here? Talk it over with your neighbors, please. Go. All right. So, to complete the square, who can give me what we need to do? Go ahead, Patrick. Divide b by 2. And then you square it, and that's how we get c. Hands if you agree with that? That is correct. This is what we call completing. This is what we call completing the square. But what needs to happen? It needs to be like this. What is this called? Tell your neighbor, please. Everybody got it? Therefore, yes. Yes. You will get there. Very good question. All right, copy these steps, please. So since we already know what the concept is and where to get the square, copy these steps. It's only 6 steps. It says, step 1, set the quadratic equation in standard form. Divide the entire equation by the leading coefficient. Eliminate the constant. Add b over 2 squared. Bam. To each side of the equation. Step 5, factor. Step 6, take the square root. Write 2 equations and solve. Copy that, please. Here goes the process one more time just to make sure we got it. Step 1, set in standard form. Do we know how to do that? Yes. Step 2, divide the entire equation by the leading coefficient. Yeah, that seems simple. Step 3, eliminate the constant. I'll show you how to do that. Step 4, do we know how to add b over 2 squared? Yes. Step 5, do we know how to factor? Yes. Do we know how to take the square root of something? Yes. Write 2 equations? Yes, and solve. So now we know how to do all that, but today's going to come together, and you're going to see how this works. Here we go. Write this down. Example 1. Yes.
The steps still say to check, but is there any way to check these?
Yes. Here we go. It says, example 1, solve by completing the square and check your answer. Equation, x squared minus 4x minus 6 equals 0. X squared minus 4x minus 6 equals 0. Now, for the purpose of today, I'm only going to walk you through all these 6 steps. We're not going to check because I just want us to get us through these steps. Excuse me. All right? So, pens down, eyes up here. Please do not write anything until I ask you to. I want you to stay your full attention on this because it's going to go pretty fast. Now, there's some steps that are going to seem redundant, but redundant means when you do something that is not purposeful, or that it's redundant. For example, watch. This is redundant. That I say, oh, I'm gonna write a number 2. Oh, I don't like how that came out. Let me write it again. Oh, I don't like that one. Okay. What do you guys notice? That all that is redundant. It looks almost the same. Is that correct? That is redundancy when you do something that has really no purpose. So here we go. But in this case, it does have a purpose because it's going to pay off when we get to a different problem. Here we go. Step 1. Set the quadratic equation in standard form. Check. It's already in standard form. Pay attention, please. Step 2. Divide the entire equation by the leading coefficient. What's our leading coefficient? 1. So if I was to divide the entire equation, we end up with x squared minus 4x minus 6 equals 0. And you're just paying attention. You're going to copy at the end. My goodness. Here we go. Step 3, eliminate the constant. My constant is negative 6. That means I need to add 6. Add 6. I bring everything else down. X squared minus 4x. I leave a space equal to 6. And that's why now we're going to complete the square, which is step 4. Step 4 is add b over 2 squared to each side. So what is b here? Negative 4 over 2 squared. Add negative 4 over 2 squared. Are we there so far? Now, before I move on to step 5, I'm going to simplify this a little bit more. Let's see. X squared minus 4x plus, what is negative 4 divided by 2? Negative 2 squared, that's positive 4. So this is 6 plus 4. I can simplify this a little bit more. X squared minus 4x plus 4 equal to 10. So let's see so far. Standard form? Yes. Divide by the leading coefficient? Yes. Eliminate the constant? Yes. Add b over 2 squared to complete the square? Yes. And I simplify that so far. Copy that, please. Yes. Sorry. Step 5. We're in step 5. For step 5, it says factor. Pay attention to this part. Factor. If I was to look at this only, we already know how to factor this, right? GCF, power rating, so on. However, what is this called? This is called completing the what? Square. So now we know something about this trinomial. This is a perfect square. So now we can actually use a shortcut. Copy that, please. Okay. All right, here we go. So, look up, please. Process. Standard form, yes. Divide by the leading coefficient, yes. Complete the square by adding b over 2 squared, yes. We simplified that. We factored using the shortcut because we knew this was a perfect square. Is that correct? Yes. We're at this point. Look at the last steps. Pay attention, please. To solve for x here, I need to leave x by itself. But there's a dilemma. We have this squared. If we were to use inverse operations, what cancels a squared? Everyone? A square root. This cancels this, and whatever we do to one side, we do to the other. Now check this out. This is how I'm going to write it. X minus 2 equals plus minus square root of 10. What? Does everybody know why we write plus minus? Okay. Square root of 16. What is square root of 16? Plus minus 4. Right. That's why we write plus minus. Copy that, please. Copy that. It says square root. Did we do that already? Yes. Before I write my two equations, pay attention, please. I need to leave x by itself. What do? Add 2, so I end up with x equals 2 plus minus square root of 10. Now I write my two equations. X sub 1, and now you can be writing this with me since you already know the last step, right? X sub 1, x sub 2. X sub 1 is what? 2 plus square root of 10. What is x sub 2? 2 minus square root of 10. And for the purpose of time today, I'm going to go ahead and leave it like that. These are my, we already solved, these are my roots, x-intercepts, zeros, solutions. This will be the answer, yes. Now, if I was to ask you to find me the actual decimal, you'll find me the decimal because you would need it to graph, right? Square root of 10 is somewhere in between 3 and 4, so it's 3 point something, right? So what is 2 plus 3 point something? 5 point something. What is 2 minus 3 point something? Negative 1 point something. So now we have some information to graph. Everybody understand? All right? So, fairly simple? Okay. Well, we would graph it if this would be a perfect square, but for right now, we can leave the answer like this. This will be your solution. Okay. So when you get to on your home plate, if you get some of these that are not perfect squares, you can leave them as radicals. Okay. Yeah. Fine. All right. Here we go. Move on to the next one. Copy this one. Example 1Q. 1Q. X squared minus 6x minus 16 equals 0. Let's do this one together, see if we can go a little bit faster. Okay? So, step 1 says set in standard form. What do we notice? It's already standard form. Okay? So we go to step 2. Step 2, divide by the entire equation by leading coefficient, which is 1. I'm going to do that just for the purpose so that you can see it. X squared minus 6x minus 16 equals 0. Yes, when you have a number, you divide by the number. You need to write it down. I want to see the process. It's muscle memory, guys. It's kind of like if you tell me, Mr. Q, do we have to shoot 53 pointers? Yes, shoot 53 pointers. What if I make 3 in a row? Can I just stop at 10? No. Shoot your 50. Next, eliminate the constant. So what do we do, everyone? Add 16. Add 16. We got x squared minus 6x, leave a space, equal to 16. Next, add b over 2 squared to each side. I add to each side, add to each side, b over 2 squared. What is b? Negative 6 over 2, negative 6 over 2. All right? So before I go to factor, let's simplify this, yes? Yes, Mr. Q. All right, good. X squared minus 6x plus what? Plus 9 equals 16 plus 9. Can we simplify this a little bit more? Yes. X squared minus 6x plus 9 equals 10. Oh, my bad. Sorry. Equals 25. Yeah, I was trying to see if you're paying attention. Let's go to factor. Do we know the shortcut already? Why do we use the shortcut? Wow. Because it's shorter. Wow. Because it's a perfect square, my goodness. Square root of the first, x, square root of the last, 3, sine of the middle term, minus, so this is squared, equals to 25. All right? So we need to solve for x, we need to cancel that square. So what do? Square root. This cancels this, and we do the same to the other side. We're left with x minus 3 equals plus minus square root of 25. We'll simplify it on the next step. All right? So we need to leave x by itself. So what do? Add 3 to both sides, and now we can simplify that radical. X equals 3 plus minus what? 5. And now we write our two equations. Two equations, x sub 1 x sub 2. What is x sub 1, everyone? 3 plus 5, and that is 8, so we solved already. 3 minus 5, and that is negative 2. And these are my x-intercepts, my roots, zeros, solutions. Yes? X plus 3, yeah. All right, so let's graph this. Now that we can graph, right? All right, so let's graph this. We got, what is our y-intercept, everyone? Negative 16. And our roots? 8 and negative 2. Is this a frown or a happy face? Happy. Okay. Yeah. Okay. Notice on this one, we did have a perfect square right here. We were able to get that, and that's how we ended up graphing, right? Yes. I try to keep x sub 1 the positive one. But if you want to flip them, it doesn't really matter, but keep consistent. Okay, copy this next one. Example 3. 3x squared minus 5x minus 2 equals 0. I'll give you a head start. Do the first 3 steps. So 3x squared minus 5x minus 2 equals 0. Copy that and go. Okay, let's see. Step 1, standard form? Yes. Step 2, divide by the entire equation by the leading coefficient. So we divide by 3. 3 divided by 3 is 1, so we're left with x squared. Negative 5 divided by 3, that's negative 5/3 x. Negative 2 divided by 3, that's negative 2 over 3. And all that equal to 0. Hands if you got up to right there. Okay? Step 3, eliminate the constant. Hold on, let me show you the next step. Add 2/3, add 2/3. We end up with x squared minus 5/3 x blank equals to 2/3. Now, before I move on, hold on. I'm going to add b over 2 squared. So pay attention to this part. Pens down. Just so that you see how this works. I'm going to add b over 2 squared. What is b? Negative 5/3, right? Negative 5/3. But instead of writing over 2, what should I write? Divided by 2. Negative 5 over 3 divided by 2. And that should tell us something else. That we have negative 5 over 3 divided by 2 over 1. This becomes negative 5 over 3 times 1 over 2 becomes negative 5 over 6. Did you see that? So, home plate for tonight. Let's see. Home plate. Tomorrow we're going to do some more practice of this. It's found on page 592 only. Hold on to your home plate from last night. I'm going to pick that up tomorrow. Have a good one, everyone. It's your home plate. See you guys tomorrow. Bye.